Okay, so we want to find the limit of this mess. Whenever you're doing limits, the first thing you should always do is just see if you can take this number and plug it in. Meaning, I could try to plug in 0 times cosecant of 11 times 0 over cosine of 16 times 0. So I see the top's 0, and the bottom in this case would be the cosine of 0. But the problem is even though this is 0 times something, unless you recognize that the cosecant, remember these trig identities that you all love? This is the same thing as 1 over sine. And now are you going to divide by 0? We hope not, right? So can't do it that way. So I have to think about some other things I can try. When you do limits, step 1, try to just plug in the number. That didn't work. Step 2, see if you can finagle this equation. And we already said there's something I could do here. So what I'm going to do is I'm going to rewrite this equation, but I'm going to split everything up into pieces. What I mean, I'm going to put x by itself, I'm going to put that piece by itself, and then that piece by itself. So then I can kind of see what's going on. So I'm going to have the limit x by itself, cosecant 11x by itself, and then times, this is going to be 1 over cosine of 16x, right? Because all I did was pull that stuff off and just move this to the side. All right, well, this really didn't do me a lot of good if you notice, because I still have this madness. So what I'm going to do is go ahead and let's use our identity. Anytime you can change something into sines and cosines, do it. So this is my only problem, actually, because I can't divide by 0. So you look at this and you say, well, that's all and great, Cindy, but you still have an actual problem because I still cannot plug in 0. There is a limit that you all need to know, and if you look in the lecture part, I even prove it because I know how you love proofs. If you don't love proofs, you just need to know this limit. This is a nice little special limit, so let me make sure I stay on the board here. You need to know this limit. You need to know this limit. This limit says, as let's just use theta, approaches 0, because this is how it's written in your book. The sine of theta over theta equals 1. And again, there's a proof of that, but most students, after you go through the proof or not, you just memorize that. Well, because of the sandwich theorem, because you've gone through that as well, I could rewrite this way with the 0 up top and sine of theta on the bottom, and that still gives me a 1. So I look over here and say, wow, wouldn't that be nice if that was theta and I had a theta up top? Well, I can do that. I mean, I know you love when math people just do whatever you want, right? You can do this because I can, as long as I just multiply by 1. All right, so let me just write all this junk again. Sine of 11x, and then I'm going to put me a little space here because I'm going to need it. Cosine of 16x. So as long as I just multiply this by 1, I'm not changing the problem, right? Because all this is being multiplied. Well, I can write 1 as 11x over 11x. Isn't that still 1? I think so, right? And so I haven't changed, nothing has changed. This line is still that same line. But if you notice now, I have 11x over sine of 11x. That's this business right here. It's just in this case, that looks like a 0, that should be a theta. In this case, my theta is 11x, 11x. So what happens is this piece, if I throw it on top of here, this limit is going to end up being 1 because of the definition. As you see, I can cancel this x with that x. So I've ended up with an 11 here, and that's still in the denominator. Okay, so that's, this came over there, so that's 1 over 11. And then if I plug in 0 now, the cosine of 16 times 0 is the cosine of 0. The cosine of 0 is 1. 1 over 1 is 1. And hence I get my answer. Ta-da!